Hey, how's it going? Today I'm going to be talking about performance and what that is. The number of videos up to this point, I'm constantly discussing the same issue or problem that I'm looking to solve. I'm focusing on software solutions, right? In computer science, performance refers to measurements and evaluation of how well a computer systems of software applications are operating. It encompasses several aspects related to efficiency, speed, and resource utilization of computer systems. Performance optimization is crucial to ensure that software and hardware systems meet their intended goals and provide satisfactory user experience. Satisfactory is setting bar perhaps very low. So perhaps there's a better way to put it. If we were to break down all considerations related to performance with regards to computer science into particular steps or measures that can take into account, we were to begin with execution speed. The time it takes to program or algorithm to complete its task. Faster execution is often desirable, especially in time critical applications. Resource utilization. Efficient uses of system resources including CPUs, central processing unit, memory, RAM, disk space, and network bandwidth. Effective resource management is essential to provide bottlenecks and system slowdowns. Just some of the measures. Next point would be scalability. But if anything, I would like to rephrase that and perhaps sharing my own understanding of how the systems, whatever you might be developing, they need to be able to undergo a lot of stress, right? So the systems need to be capable of scaling, or system that you were to develop need to be flexible enough to undergo a lot of stress. I don't know if it makes sense now, but once you start developing any product or services yourself, you would understand what I'm talking about right now. Response time, the time it takes for a software application to respond to user inputs or requests. Low response time are crucial for responsive user interfaces and interactive applications. Perhaps it's worth mentioning is just something some of the governments up there in the world, I really want to use this example, but I don't know how good of an example that is. If some of the government institutions, right, they can reduce speed of internet to some of the applications or websites up there, so less users would go to particular websites or users, right? So even that's something that governments can potentially do, and by doing that, that's sometimes or based on experiences, real life experiences, this is what actually works. So they can reduce response time, latency, increase or reduce speed, how fast applications might work, and by doing that, they can reduce number of people interested in even visiting some of the websites or going to certain applications. Algorithmic complexity, analyzing the time and speed complexity of algorithm to choose the most efficient one for a specific task. Algorithms with lower complexity tend to perform better compared to counterparts, as well as different levels of databases that they're communicating with or fetching information from. It even is some of the websites up there without promoting any company, right? So depending of how they pulling some of the data on the website, more likely a lot more people would go to different websites depending on what would be posted on the websites, or how let's say we're taking 100%, right? If we were to take 100%, if we're looking at some of the projects up there where you can potentially find pictures, so how many of 100% of some of those pictures would be about cats playing games? I don't know. So it would be 10%, right? So 20% of those pictures perhaps would be news, and perhaps 40% would be people that you know of pictures. The rest of that would be general pictures that perhaps high interest pictures that had a lot of defined, but some of the projects up there they have received a lot of perhaps views, likes, whatever the case might be, right? So if that's the algorithm, right? So depending on that 100%, so based on that experience that those projects are offering to their users, more likely they would generate more people going to those particular websites. It's something that if yourself you haven't put any attention in until now. Once you would begin developing different projects yourself, you would start understanding what I'm talking about. Code optimization. Writing and optimizing code to improve its running performance. This may involve techniques like loop unrolling, algorithm improvements, and minimizing unnecessary calculations. Caching, using caching mechanisms to store and retrieve frequently accessed data, reducing the need to recompute or fetch data from slower storage devices. So overall, where you storing that data and how far the data can be is something that's edge computing, right? So some of the software solutions are there that they're looking to optimize where the information might be stored. Profiling and benchmarking. Profiling tools are used to measure the performance of the code, identifying bottlenecks and areas of improvement. So something that potentially can be overcome. Benchmarking involves computing the performance of different algorithms or implementations. Memory management. Effectively managing memory memory allocation and deallocation to avoid memory leaks or excessive memory usage. I/O performance, optimizing input and output operations such as file read, writes, and network communications to reduce latency and improve overall system performance. Load balancing, distributing networks eventually across multiple servers or resources to ensure optimal resource utilization and avoid overloading of any single component. For people out there who are interested in bettering themselves, becoming more effective and higher performance individuals, I have made this tool. It's Inkflow and it's a quarter planner where if you are interested in optimizing your time 24 hours and how to make most of your time, I have identified different areas within this journal which I personally believe are important and to overall develop a habit. That will last potentially. So if you were to begin with taking one day at a time and optimizing your time 24 hours, and from there do that for a quarter, right? So for a number of days, hopefully to develop a habit that will last. That would bring you, or to the least, give you necessary tools to become a higher performance individual. You can find this in the description below, as well as Top Retailers has it. Overall, just to summarize this video, performance is something that's really important, perhaps not in the beginning, then it should be in your when developing a project, perhaps not in the beginning. First, you were to develop a project to solve a problem. Once you develop the project, it solves the problem, then you need to improve quality overall of the project. Then you would be looking at performance. So overall develop a project, and from there, once you would like to improve the quality and optimize your project, then you were to look at performance. So overall performance optimization in computer science involves combination of algorithm design, coding practices, system architecture, and hardware considerations. It is fundamental aspect of software development and system administration, ensuring that computer systems and applications meet user expectations and function effectively in various environments. As I mentioned, that would be overall quality, right? So once you've got project solving a problem, or how it intended to solve the problem. Once you got it, from there you need to take a look at the quality of the overall product and services that you offer, and improve the quality. But that would be overall steps that you need to take. Thanks for watching. Let's see you in the next one.